Here's an example of using technology to do a chi-square test using some of the problem in the online homework. In this problem, it's asking about their association between smoking cigarettes and smoking marijuana. And so we give us some data. And the first thing they do, in this question, they're actually asking us to do this two ways. They want us to just change the things into proportions and discuss it. And that'll be kind of like what we were doing in the first unit for this course, where we just sort of looked at the numbers and said whether we thought they were different or not. And then the part B for this is going to be to actually go through the 5 steps of the chi-square test. So it'll feel a little odd at first because we're going to not use the chi-square test for part A, and then we'll use it for part B. So it starts off asking us to just convert the table of numbers into a table of proportions. And so you can see I already have the answer in there because I went ahead and did it. Can I get that smaller? Yeah. So to do that, what I'm doing here is taking my explanatory variable, which I think cigarette smoking leading to marijuana use, I think is probably what they're trying to study. So we have our cigarette smoking as the explanatory variable and using marijuana as the response variable. But to do this, I need to have a total for the columns here. So the first thing I would do is add totals on, because the percentages I want to convert these to, I want to know the percentage of cigarette users who use marijuana, yes or no. And then I want to know the percentage of non-cigarette users or non-smokers who use marijuana, yes or no. So to make those, to get those proportions, I need to convert these things to, I need to add the total for smokers and non-smokers. And I'm just now realizing I don't have a calculator. Hang on a second. All right, so 927, so I'm doing the total number of smokers, so 927 plus 594 is going to be 1,521. And 45 plus 76 is 771. So to turn these into proportions, I just need to do the division. So if I want to know the proportion of smokers who use marijuana, that's going to be a division by 1521, because that's the total number of smokers. Remember how I was saying whatever word comes after proportion or percentage and be of something, that's the number. I want total number of smokers as my denominator, right? So whatever the proportion is of, that whole should be what we're dividing by, and then the number that we're dividing will be the numbers who use marijuana. That'll be 927 of the smokers use marijuana. So the proportion should always look like a part divided by a whole. We have total number of smokers, and then we have the number of smokers who smoke marijuana. And that's where we're getting those numbers from the table, and that is where I'm getting 60.9% rounded to one decimal place like they've asked. So if I do that for each of the 4 things, my other proportions are going to be 594 over 1521. That's the percent proportion of smokers who do not use marijuana. So that's what the 39.1% is going to be. Then I'll have the proportion of non-smokers. So the proportion of non-smokers who use marijuana will be 5.8%. And the proportion of non-smokers who don't use marijuana is 94.2%. So we can convert the original counts into proportions of smokers who answer yes or no to the marijuana question and proportion of non-smokers who answer yes or no to the marijuana question. So when we're trying to see if there's an association, these are the numbers that we're comparing to see if they're similar. If there were no association, these numbers would be roughly the same. If there was no association, these numbers would be roughly the same. They are really, really, really nowhere close to being the same. So that's why for the first question here, after we converted the percentages, I picked answer A, which says the data suggests that marijuana use is much more common for those who've smoked cigarettes than for those who have not. I think that the percentages bear that out. So that's the way we looked at this back in the first unit, and there was a question like this on the first exam, and this was basically the level of the analysis that I asked you to do on that homework assignment that you turned in a couple weeks ago, or I guess it was last Monday, whenever it was. Okay, so now if we're going to do an actual chi-square test, so that's the second way we're going to do it. The first thing it asks is about our assumptions, and again, our assumptions are always that everything is random, all sampling is random, and that we have enough data. And the threshold for enough data is that we have some expectation that each of our counts will be at least 5, and certainly in this case that's true. The second part of the hypothesis test is to set the null and alternative hypotheses. And as I was saying in class, the nice thing about chi-square testing is that these are always exactly the same. There's always 2 variables involved, and so the null and alternative hypothesis are always that the 2 variables are independent and that the 2 variables are not independent, or what we could say dependent. So the only variation in that is the fact that the language of has an association or doesn't have an association is just another way of saying those 2 things. And so sometimes you'll see a variation in the language, but you never have to make a decision from the problem about what the hypotheses are. Oops. So in the problem, it has a little button that says open this up in StatCrunch, or copy a cell out and paste it into StatCrunch. So one way or the other, you can get this to pop out to be in StatCrunch as shown here. If you're using the other applet, the one that I showed in class that you don't have to be logged in to use, you can also do that. And if you follow the instructions in the other video, you'll see screenshots of what that should look like. But I'll just continue on with this one in StatCrunch. So in StatCrunch, if I open it up with the data that they gave me, this is what it looks like at the top here. And you'll notice one weird thing about this is that they actually put in the first column, this is not a variable, in the first column for these things, they actually put the names of the row variables. So that's a little bit different than what we've seen before. But these are just the counts from the problem. So after we have our data in there, we pick stat, tables, contingency, and we're going to ask it to do this with a summary rather than with the data. In the data project you're doing, you'll pick with data because then it will do all the counts for you. But with summary means that we're not providing the 2,000 different responses to these questions. We're just entering the counts. So this is considered a summary of the full data set. The full data set would have 2,000 rows of people's responses. So that's what we choose. We get the menu here. Again, so this is where it asks about the row label. So this is the name of the column where the row labels are. So that's kind of weird. And then our columns for our actual table are the marijuana yes and the marijuana no. So of the 3 columns that have numbers in them, the cigarettes are actually just the. So of the 3 columns that we have in that table, the first column is not really data. The first column are just the labels for the rows. So that's why I tell it here, those are my row labels. And remember that said yes or no. And then my columns of actual counts are these 2, marijuana yes and marijuana no. So I pick those to be where my data, my counts are, and I pick cigarettes to be where my row labels are. When I'm doing these, I always want to pick expected count here. I don't know in advance whether the problem is going to ask for that or not, but it's nice to have. If I had picked row percent instead, then it would have, then this would have told me the answer to that first question that I did by hand. So you can experiment with these different choices. And of course, chi-square for independence is what we're really doing here. So when I do that, this is the output. I can see my the original data is in here. It puts the totals here, so I know that I got that right. I didn't have any typos. And then in parentheses, these are the expected counts. In other words, these are the counts that I would have seen if there was no association between smoking cigarettes and using marijuana. And you can see how far apart these are. The expected number here would be 327 people should have said no here, but only 45 did. And only 645 people should have said yes here, but 927 did. So we can imagine that the chi-squared value for this is going to be large, and that's exactly what happens. It's an enormous chi-squared value. And because it's so big, the p-value is definitely very, very small. This is the smallest thing that this applet will say. It'll just say less than everything, less than any number that you could imagine to 4 decimal places. But it's really 0.00000000. Got lots and lots of zeros there. The picture for that, just for completeness, the chi-square distribution starts off here and kind of tails away like that. Usually drawn better than that, but that's what it's supposed to look like. And so a chi-squared of 636 is super, super far out to the right. And so the p-value is always the area shaded to the right of the chi-squared value. So if the chi-squared value is enormous, then there's very, very little area to the right. And that's what that's saying. So in the homework, it just wants me to tell it the chi-squared value to the nearest integer. So there it is. That matches that thing rounded to the nearest integer. And then the 4 decimal places, this is basically saying you can give up on it. The first 4 decimal places of this are definitely all zeros. And probably the next 20 decimal places are zeros. But that's this is the smallest number that it's going to tell you. Remember, it doesn't really matter what the p-value is exactly. Our conclusion is based on whether the p-value is small. And so just telling you it's less than 0.00001 is enough information to move forward. So then our conclusion is going to be that the p-value is small. I'm just going to write it down. I know they do it multiple choice, but p-value is small. And in fact, it's crazy small. So we could say we strongly reject H0. You could say very strongly. You could say crazy strong. But this p-value is really, really tiny. We strongly reject H0. And so we have support. And again, you could say strong support in this case, because the p-value is so small. And really you're going to put strong support for HA. That's what you're going to write here. So what I typically will try to do is restate HA in words. And so if I go back and look at what my original choice for HA is something like smoking and marijuana are dependent, or you could say smoking and marijuana are associated. So this is evidence of a strong association between cigarette smoking and marijuana use.